basically, agenda for today is as follows. We will present you and introduce you what we mean by STIFware and what are the concepts behind it. We're going to present you with the first generation of STIF, which had to fulfill the following goals. We had to automate, integrate, and unify the data exchange and integrate all of the tools together. Then we're going to run a demo for the first version of the STIF. After that, we will explain to you what were the problems that we faced when we were developing STIF, and then why are we moving to the STIF 2, which is like a next generation. And then we're going to talk more about STIF prototype. After the presentation, we'll give this T-shirt that was being given to us by Hack in the Box crew, but we have basically a bit modified it by hand.
It's a modified version, like a stencil on the top, and an industry slave, because it's the ideology behind the STIF thing. And we will award it to the best question
yeah.
bringer.
Yeah, the best questions gets the T-shirt. Let's get going.
So basically, to introduce a bit what is the STIF framework, you can see that STIF is like a shortcut for STIF tool integration framework. And basically, the main purpose of the STIF is to have heterogeneous, like various tools to be unified in a single environment, so you can use them from a single spot basically, and to automate as much as possible execution and like all the routing work which has to be done in order to succeed in a network penetration thing.
Well, in simple words, it's basically a platform for automated hacking, whereas we have integrated using our inference engine all of the tools where you only have to issue one command, say add a target to the system, and the whole inference based on the rules, the inference engine will deduct what tools needs to be run based on the output of previous tools.
Yeah, basically we consider the tool to be like completely legal, so it's just up to you what you're going to use it for. So we don't consider hacking to be illegal, but we consider illegal hacking to be illegal, so that's the thing.
Yeah, why do we need automation in the first place? First of all, we need to have a machine-based knowledge process, and that is where we can outsource in some way these repetitive tasks to the machine, so that our brain could be freed for some more creative things. Like, as I said, yeah, one of other ways to use automated tools is basically create intrusion scenarios where you could either stress test or do evaluation testing of different network intrusion detection systems using the scripted out scenarios. Another reason for that is to mitigate the human error which can occur due to imperfections of our
Yeah, if you
brain.
do like certain tasks repeatedly, you can test like one thing once, but if you have to test like 100 times, there are chances that like one of like dozen things you're gonna miss.
Yeah, and ultimately we want to reduce human labor involvement in the modern penetration testing sweatshops.
Yeah, that's what the T-shirt is about as well.
Yeah.
Basically, why we need the integrations thing. The situation right now is that we have a large number like of the security tools which exist, but there is no way how you can like hook them together. There were some attempts to do this stuff like in a small scale, such as Metasploit framework. It's like a very good tool which gets all the exploits together. But still, if you want to automate the whole process, if you want to do like scanning, network sweeping, network mapping, and then like automate it, like exploiting all from the single box or like from the single system, there's nothing existent on the moment which can do it for you, roughly. Well, I think there is core like the product by Chorus, which is basically like a set of Python scripts which supposed to help you to do like penetration testing thing, but it's not really automated and it's not really free. Another thing that we want to be able to collect all the data and like convert it into format which we can store in database, so we can do like machine-based processing, like data mining and stuff. Because for a single network, it's cool, like you can like manage it by hand. But when you have like an A-class segment, there is no way how you can like go through all the text files and like analyze them like effectively.
That's a typical scenario that takes place now with security analysts maybe not using all those fancy scanners that give you these templated reports, but actually does the whole process by hand, which is a lot more, which brings a lot more quality in it. The way it works is the analyst first analyzes the results of the output of the tool, or if it's like a first time, he analyzes the target that he has and feeds that into security tools, and then analyzes again the output, and then based on that makes the decisions.
Yeah, basically, just to note, we're trying to avoid the word hacker throughout the presentation because of the media created image, so we'll use the word security analyst or security professional for the thing.
So yeah, if you want to see what happened to the Joe, the analyst after 1 month of these repetitive tasks, yeah, poor Joe.
Yeah, he turns into monkey.
So why don't we let the machine do the boring part, where we, as I said, outsource all these repetitive tasks to machine?
Yeah, there are actually other ways how you can solve this problem. Like one of the things which we used to do before, we used to write scripts. Like for every task, I would script it out, and I ended up with a bunch of scripts. I think it was over 1,000 scripts laying all over my hard drive. You can use the security scanners to a certain degree, but scanner is just a scanner thing. You can use for certain particular tasks, you can use exploit toolkits and things like that, or you can hire a room of pen testing monkeys and ask them to do the thing.
So one question that you should have by now. So what's the difference between scanners and STIF? I mean, it looks like it's the same thing where we have integrated all the tools. Well, there are several problems with scanners that we have today. First of all, is a hard-coded sequence of execution. All of the scanners today follow this pattern of the penetration tests, where they gather information, analyze it, perform vulnerability research, and then try to exploit the vulnerability and then escalate the privileges.
In fact, scanner doesn't really do penetration tests for you. What it does, it just does certain stages of network gathering, and to the most that would be it just does scanning, and then it does port mapping.
Yeah, well, it depends on what kind of scanner we were talking about here. But yeah, the second problem is vendor-specific integration. That is, to integrate different tools into these currently existing scanners, you need to follow some specific API or some specific language like NASL. You need to follow some plugin APIs, which require code rewriting and basically hacking of the code of tools. And the last thing is that each vendor currently represents all of the data in their own format. If you see now all the tools, most of the tools now actually provide you with XML output. But the problem is there is no use for that XML output, since you have to write the parsers for it, since every tool actually represents it in its own format. So it's not that useful.
There's no way to actually have some sort of unified processing of the data, because there are so many various forms. Yeah, and at this point we thought, why we just wouldn't write one? We'll write a framework which will help us to unify the data, have some sort of common format to represent the data, and have some common framework where you can just plug the tools in and you can let them run and collaborate together. So make the STIF.
First generation of STIF provides several features. First of all, it's a highly customizable rule-based inference engine, which enables a security analyst to script out any scenario based on the data that was returned by tools. That is, we have created a framework and then created the different converters for different tools that actually convert all the data into unified format, and you can actually operate with that unified format to script out scenarios of execution. That is, you can say if you see port HTTP and, for example, IIS running there, you could launch some exploit based on that. Later on during demonstrations, we're going to show you how the rules looks like and how it all works. Secondly, it provides unified data exchange and representation format. That is, we have a set of XML messages that actually enable you to represent most of the data returned by currently existing security tools. Then we have a generic database publishing module, which could be quite useful for anyone who has their own custom database scheme, and then they want to import the data from tools into their database. using our generic data or the data from the tools into a database of any scheme. And also we have a data publishing and importing interface, which was implemented again as one of these things. We did it in IRC, so that means that you can actually connect several Steve agents, basically Steve nodes, through IRC, and they would collaborate and exchange the data over the IRC and perform the
you basically
automated
connect
hacking.
them to the single channel, and on the different nodes they can actually talk to each other through the channel by exchanging the Steve messages.
Next is the distributed architecture. As we said, employing the IRC, you can actually have several nodes, several operating systems running, different operating systems with different tools on them. And if you write all the rules properly, all of them will be working together to achieve, to basically to execute all of the tools in the sequence that was given by you based on the output of all of the tools. We have a ready-to-use database schema. At the moment, the first generation Steve was written in Java. The reason for that was because it was really quick to develop things in Java with all the multi-threading in there, and again, cross-platform capability.
And the other thing which we are trying to solve is data representation unification. And in the first version, like the first generation of Steve, we developed an XML format which we call Steve message, which basically encapsulates all types of data that is relevant to the network mapping and like network intrusion things. So we have XML format for like host users, ports, URLs, user IDs, users, passwords, vulnerabilities, stuff like this. In the second generation, we'll move to it later. We actually expand it a little bit.
So this is a simple Steve message. As you can see, this one was taken from the output of Nmap. So what it tells you is that there is an open TCP port number 80 on the IP address 192.168.1.1 that has HTTP protocol running there with application of Apache 1.3.27 with PHP.
Yeah, and basically what happens, like in sense of information, in sense of like data flow within the Steve, the information within the Steve is stored in format of the Steve messages. Whenever a tool has to be executed, the data is being converted from the Steve message into the format which the tool can understand by the tool execution tool wrapper module. The tool is being executed, and then the execution module is actually parsing out the tool output and converting the format back into the Steve format and injecting it into the Steve knowledge base.
Our inference engine. Well, inference engine that we have created is responsible for data exchange between various tools. That is, each tool basically injects the Steve message into the inference engine. An inference engine, based on the rules that analyst has created, will make a decision on what tool to run next and what arguments to give to the tool. Again, we will show you the rules later, so as soon as you see the rules, it will be a lot more clearer for you how it works. But basically, inference engine is the one that's responsible for deciding what tools to run and what input to give to these tools from the Steve messages. Yeah. Inference engine operates only with Steve messages.
Yeah, the inference engine is actually the media which takes the messages from one tool, reroutes it, and like sends it to the other tool. And the inference engine, like, it's equipped with a rule base which tells the inference engine what sort of messages should be routed to what sort of tool. And we also have a data publishing facility. We have a unified data publishing interface, and we have like two implementations right now. One of them is a database publishing interface, and one of them is the IRC publishing interface. But if you're really interested, you can actually hack one of your own. We only have the interface, so as long as you implement the interface methods, then you can have like a publishing interface of your own. And
yeah, this SQL publisher, that's what I was talking about, where you can actually save the data, save the output of different tools into your database. So this below shows you the sample entry in the configuration of SQL publisher. As you can see, for the message type of target, that is whenever you give IP address to be inputted into the system, the following query will be run with %h being substituted